We are live now.
Oh, okay. Hello. Hi everyone. My name is Mikhail Fedosin, but you can call me Mike. I'm a senior software engineer in Mirantis, and I work as an upstream developer in Glance project. So, Nikhil asked me to introduce our new service. It's called Glare, which means Glance Artifact Repository. By the way, are you familiar with Glance and how it works? Uh, I bet you know the basics because you have been working with it for last, I think, 2 days. So I don't want to stop too much here and go directly to Glare. So how we define Glare? Glare is a service that provides an access to a unified catalog of structured meta-information as well as related binary data. These structures are also called artifacts. This catalog is highly customizable, and it allows operators decide what artifact types they want to deploy. So, you may ask me, what is artifact type? Uh, Artifact type is a description of artifact. It defines what properties artifact may have, their types, mutability, possible restrictions, and so on. A good example of an artifact type in Openstack is a glance image. It contains some meta information like name, owner, date of creation, and of course some binary data image file. Glare was conceived as a generalization of glance, which improves it in many ways. It's always a hard question. Why not glance? Why we are going to create a new service? So the answer is the innate limitation of glance is that it operates only one hard-coded data structure called images, and it is used essentially only by Nova. However, many other OpenStack services like Heat or Murano or Mistral also have their data structures and need to catalog them somewhere. Unlike Glance, in Glare operators can choose which artifact types they will maintain in their cloud. The rest of the working principle is very similar. Glare allows creating immutable objects with some meta information, uploading and downloading files, sharing artifacts between users, setting tags, and so on. But Glare also gets some nice optional features, such as artifact versioning, which means that each artifact can be supplemented with the version in sameware format. Also, it support of multiple binary objects per artifact, because currently an image contains only one binary attribute file. From Glare's part, it allows you to specify a set of such attributes. Also, Glare supports structured properties, which means that artifacts may contain some structured properties like dictionary or list. For example, dictionary of strings or list of integers. And finally, it supports dependencies between artifacts. It means that one artifact may depend on the other. Some people ask me, what is the difference between Glare and Swift? They have to understand one thing. Glare uses Swift as a backend to store files and just catalogs links to external Swift servers. But Swift is just one of many possible backends for Glare. Operators can also use Ceph, Amazon S3, Sheepdog, VMware Store, and others. All binary data operations are performed with the Glance store library that allows working with a chosen store. So now I'm going to tell you how Glare is organized, about its architecture. So to see how Glare is organized in detail, let's look at the picture. Now I'm going to share my screen. Just a second, please. Yep. Share. Yeah. Uh, do you see this picture, Nikhil? I hope you can see it.
Yes, we can see the picture.
That's great. So, how glare is organized? Uh, First of all, glare is extensible. In fact, glare only defines a general purpose interface and organizes a unified REST API to interact with installed artifact types. But data structures and methods of the data processing and storage are defined within the artifact type. In glare, the only obligatory artifact type is the image that implements Openstack Image API version 2. Other types are optional. So, let's go to the picture. With blue color are shown things that initially shipped with glare. Uh, Violet means that glare may use some third-party DB APIs, custom artifact types, and various data storages. So on top level, there is a router and REST API. API is common for all artifact types, and we have a blueprint that specifies it. I will share a link later. In short, there will be methods to support artifact lifecycle, like create, update, get and delete, listing artifact with filtering and sorting, uploading and downloading binaries, sharing them among users, tagging, and setting some metadata. So then it comes the engine. Engine encapsulates all logic with policy enforcement, notifications, artifact access, quota checking, and so on. For example, if you want to upload some binary to artifact, engine will sequentially check if you are an owner of the artifact. Then it will check your permission to perform uploading based on policy JSON file. After that, it will check if you have enough amount of disk space on to store your file. And finally, it will send the notification to the message queue. Base artifact type is an abstract class that defines base interface for all other artifact types. They must inherit from it and re-implement all required methods like create or save to DB. After that, they have to set type version and define its name. Then it comes the layer of artifact types realizations. There are two ways of installation artifact type in glare. Some types are bundled with glare initially, and they are located in glance repo, in glance/objects folder. They are so-called blessed types, and they are considered as stable. Another way to define type is put it in a separate library that contains user artifact types. It will release more often than Glare, about 2 months against Glare 6, and it allows users to update their artifact types more operatively. Glare's interaction with DBs is implemented with Unified DB API, which contains such methods like getById, create, for example, getAll, setTag, etc. Each type interacts. Uh, 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 Wait a second. I hear myself, by the way, Nikhil.
Hey, yes, you are still online, so
Yeah. Mm. Ah, ah, just one. Ah, yeah, finally. Yeah, my screen is shared. So about unified DB API. Each type interacts only with this unified API that maps to the existing DB API realizations. It allows artifact types to be independent from DB and support several different implementations of DB API. So for example, by default, image type uses the existing image DB API, which has method getImage that requires image ID as a parameter. On the other side, Glare DB API contains method getArtifactById,
Hey,
but they
Mark,
both are, yeah.
sorry to interrupt. We are not seeing your screen share.
Seriously, oh, sure, here it is, yeah. Sorry for that. So, what I was talking about. Uh, so, I mean that both these realizations are hidden under the unified interface method getById, and it allows type developers not to think about DB API implementation, use unified API for their types. Operators from their side may choose what DB API will use for a type without any code modifications. Interaction with object stores is organized with data API provided by Glance Store library. In other words, all the binary data operations are performed using this library, which is responsible for interaction with external object storages like Swift, Ceph, or even local file system. So I think that's all I wanted to tell you about the project. So now let me describe the current status and future development. First of all, Glare is already here. You can deploy it within OpenStack and play. But only experimental v0.1 version is available, and at the moment. It has some lags and don't approve neither by OpenStack API Working Group nor DevCore. So you don't need to investigate it so much because it will be deprecated after v1 will have been released. v1 is under active development, and I hope it will be available in Newton. But now I'm going to present you a short demo with the existing v0.1 API. Here you will see how to create an artifact, upload and download some data, update properties, activate artifact, and finally delete it. So now I'm going to share my console. I'm going to stop sharing the screen. And where is my console? Yeah. So I hope you see it.
Yes, we
It is it is rather small, but anyway. So here we have pure DevStack with enabled Glare service. To enable it, you need to specify a special service in your local RC file. It's there. DevStack, Vim local C. And here you can see G minus Glare. When you specified it in enabled services, you will be able to create artifact and work with artifacts with Glare. So first of all, I'm going to source myself. Now I will present you how to install new artifact type. It will be image from Glance. First of all, I go to opt stack Glance, Glance again, contrib. Here you can see plugins. Let's go there. In plugins, there are two possible artifact types: artifact sample and image artifact. I'm going to install image artifact. Here you can see that artifact type has three versions. But first of all, I have to change a version in setup config because it correlates with PBR. Takes about 1 second. Setup. Another way we won't be able to deploy it. So as far as I remember, current version is this one. Yeah. So to install plugin, you just need to perform sudo python, I've said Python, uh, setup.py, sorry, install. So we installed the new artifact type. And now we can check what artifact types we have. First of all, I'm going to get a token from Keystone. And you have to understand that Glare doesn't have CLI client at the moment, so I will perform all requests with curl. Keystone token, I think get. Yes, oh, sorry. Here we have a token. So our first request will be to get lists of all artifacts types that deployed with current installation. By the way, of course, I have to restart Glare service. Start. And here you can see our service G minus Glare. So I'll restart it. Yeah, it was restart correctly. And yeah, let's begin with the first request. Here it is. And I think after that, Glare will show you, will show us all installed types. Um, um, it's strange. Um, oh, mhm, okay. Hmm, why it's not found? Uh, okay, I think it will be fixed later. But okay, let's go next and create new artifact. It will be performed with request like that. So first of all, we set content type as application JSON, set name, version, container format, and disk format, and send the request. Yeah, we created an artifact. Current format is really sucks here, but you can see, I think ID, where is it? Yeah, here we see an ID, and current state, I think it is creating. State creating. Absolutely right. Now, I hope we're able to list of all artifacts in creating state. Here we specify just this URL. We want to list all artifacts in images version 2.0 in queued state, in creating state. Yeah, we have only one artifact here. Exactly this one we have created earlier. And of course, we are able to see this artifact with regular GET request. So get it by ID. We created artifact with ID this one. Yeah. So it shows you some information about currently created artifact. Now we can upload some data to it. Data uploading is performed with put request, and we have to specify file. So we send this request to artifact ID /file. Data is just some string. Oh, sorry. ID of artifact is different. Yeah. Now it is uploading. Yeah, and we have uploaded this file. And here we can see this checksum, download link, how we can download it, and size. Next, I think we can change the name of the artifact. This request is performed with patch. JSON patch. So we want to change our name to, it was just image name. We want to set it new image name. And we have a patch in JSON patch format. So we have operation replace, path name, and value new image name. Let's do it. Yeah. So I think we changed the name. I'm going to find it. File owner. Yeah, so it's here. Name currently is new image name. Then to make this artifact available for all users, we have to publish it. Publish is performed with post request with special keyword publish. So here we just call post request and add publish after. Let's publish it. Yeah, and we published our newly created artifact. If we look at the state of this artifact, it was creating. Now it is active. And it means that, for example, you can't change any property of it, change data, and so on. Now I think we can download the file from this artifact. To download some data from artifact, you have to specify, first of all, artifact ID, then blob name. Here we have file, and then use special keyword download. As you remember, our data was just a strings of letters. Let's download it. Yeah, and this is exactly what we upload to our artifact, just a string of G. And the last method I want to present you is deleting the artifact. To delete the artifact, we just need to specify its ID, and call delete. Here we are. Oh, sorry. Yeah, we deleted an artifact. So if we want to get some information about it, it won't be able for us. See? So, as you may see, no artifact found. It's all I wanted to show you in this demo. If you have some questions or something, I can ask. Thank you for watching.
Yeah, thank you,
Michiel?
Mike. That was a great presentation on layer artifacts thing. Um,
Hmm.
I will let people ask questions if there are any.
With the local RC configuration, the only thing you need to do is enable that one service. There's nothing else you have to do. There's no dependencies or anything like that.
So to enable Glare in your div stack, you just need to specify it in enabled services in local RC. So no special things are required, if I understand your question correctly.
Sorry, just in the example you gave, there's like a ton of stuff in that enable service line, but you don't need any of that. You just need the G-Glare.
Mm.
So there were services like Tempest and I think
It doesn't depend on other services.
Heat and yeah,
Standalone.
yeah, it's a standalone service. And are there any special instructions for enabling the plugins?
No special. You just need to be, I think, a root, but you can deploy it with your local virtual environment. So no special requirements for installing plugins. And by the way, in Glare V1, there won't be plugins like that. You don't need to install it. It will be installed automatically. Some of them will be bundled with Glare itself, like images or heat templates. But also, we will have a special library. So all things you need to install a plugin, just specify what plugins you want to see in Glare configuration file. Nothing more. It will be installed automatically. So any other questions?
I guess that was it.
Mm. Yeah.
Well, thank you, Mike. I think this was quite useful. We'll have this on YouTube pretty soon, and you may just expect a few more questions from folks when it goes online.
Okay, thank you folks so much. Hope you like it. Yeah, so Bye.
Bye.